Hello there, Algebra 2 students, and welcome back. We're beginning Chapter 2, which is all about graphing points and lines. And this is some really important work that helps you visualize what a line might look like. So what you see in front of you now is what's known as the coordinate plane or the Cartesian plane. And this is what we'll be using to graph our points. And this probably is familiar to you, but let's assume that it's not. And let's look at point A. And what's the name of point A? And as you might know, this is the x-axis, and this is the y-axis. And in order to give a point a name, we need to tell what its x value is and what its y value is. Well, here's the x value for A, and here's the y value for A. And so the name of A is going to be -3, 4. X always comes before Y. Very simple to remember, alphabetical. Let's take a look at B. The X value for B is 2, and the Y value for B, even if it may not exactly look like it, is going to be -5. So the point B is going to be 2, -5. Get it? So now, let's go the other way. What I did here is I gave you points and asked you to think about what their name is. Now I'm going to give you the coordinates of a point and ask you to where it goes. So the x value is 1, the y value is -3. Can you see where it goes? The x value is 1, the y value is -3. And so hopefully you see that it goes right about there. And that's going to be the point C. Alright? Okay, so now let's put this to work. And what we want to do now is graph y equals 3x minus 2. And what that means is we're going to graph a line whose coordinates satisfy or make this be true. So we'll begin by making a table of values. And the table of values will give us a couple of points that'll help us come up with what this graph should look like. So what we're asking here is, alright, if x is -1, if this is -1, what does y equal? And so we just plug -1 in here. 3 times -1 is -3. -2 gives us -5. If x is 0, y is just going to be -2. And suppose x is 2. 3 times 2 is 6, and 6 minus 2 is 4. So this gives us a bunch of points, 3 points, on this line. And what we'll do is put these points on the plane, on the coordinate plane, and see what we look like. Hold on, and we'll do that. So what I've done is I've located those 3 points on our graph. Here is -1, -5. Here is 0, -2. And here is 2, 4. And if you look at those, it's pretty easy to believe that they're on a straight line. So without using a straight edge, I'll graph what they look like. And it looks something like this. So there is my line that is the graphical image of this equation. Now here's what this means, and this is a big deal, and I'll say it and then I'll write it. If you were to figure out any other points on this table of values, you would get a point that has to be somewhere on this line. And also, if I were able to find a point on this line very carefully, its coordinates would satisfy this equation. So in other words, this line is basically a picture of this algebraic statement. So let me try to illustrate this. Although it's not a great line, if you would look right here, that point looks to be 1 comma 1. And if I were to actually take that point, if I put 1 in for x, 3 times 1 is 3, minus 2 is 1. So in other words, the point 1, 1 satisfies or makes this equation be true. So let's finish up with this example. Here we want to graph 3x minus 2y equals 6. If you remember, the previous one was in the form y equals something. So it was pretty easy when you put in a value of x to know what y was. This is a little bit more challenging, and so we have to be a little bit more careful in our choice of x. But you could really pick anything and solve for y, and you'd be okay. So let's create a table of values here. Okay, so here what we're going to do is we're going to ask ourselves, if x is equal to minus 2, what does y equal? So 3 times minus 2 is minus 6. And then I essentially solve this equation for y. And you should try to do this on the side as I put the values in. And really what you're doing is solving a linear equation 3 times to get the y values. So please make sure you check at least 1 or 2 to be sure you remember how to do this. So I've filled in the appropriate values for this table of values. And what I have are 3 points. And 3 points are really more than you need to determine a line, right? Only 2 points determine a line. But 3 points is a good idea because that really forces you to see whether they're all on the same line or not, and it makes sure that you haven't made a mistake. So let's bring in a Cartesian plane, and we'll graph these points and see what the line looks like. Okay, so here's a coordinate plane, and I'm going to put these points on it. The first one is minus 2, minus 6, right about there. Okay, so that looks like about right there. And then 0, minus 3, which should be right there. And then 4, 3, which looks to be right about there. How'd I do? So now what we're going to do is draw that line and see what the graph looks like. So maybe I should use a straight edge, but I'll just try to eyeball it. Not too bad. So there you go. Every point on that line makes this equation be true. For example, let's look right here at this point. It looks like that point is 2, 0. And if indeed we put in 2 for x and 0 for y, it makes that equation be true. And you can check a couple of other points and see whether they work also. So that's what it means to graph a line. We graph a line by drawing it, and all the points on that line make this equation true, and any point that makes this equation true has to be somewhere on that line. That is a big deal.